Okay, well after last night's test we've got buzzing noises out the amplifier. Next thing to find out is does it make actual music. We have the tone arm wires here, but they're a bit short, so I'm going to have to graft a thicker bit of wire onto it. It also gives me something a bit more sturdy to attach the pins to so I can plug it into the amp. So I need to join that bit to that bit and then do that bodge that I did last night with the XLR pins. Then we'll link it up to the tone arm, get it into the jukebox, and we'll find out what this amp's really capable of. But next, it's a job for the soldering iron. Right then guys, I've wired up a bit of wire to the tone arm. It's a bit of a lash up with cable ties and electrical tape, and the socket's nothing too clever either, but it's more of a proof of concept at this stage. Hopefully if this all works and we start stripping the guts out of this and building a new cabinet for it, I'm going to go through all of this, do it all nice and properly, and it's going to look the nuts. But for now, if I can just make it make noise, I'll be happy with that. I think the time has come. Let's put in a number and see if, other than humming, we get some actual music out of it now. Let's pick a selection. Choose 1, 3, 7. Oh yes. Give it some volume. It sounds pretty crap because I'm running off some really ratty old speakers. And it's having some trouble tracking it, but it is playing. Do you know what? It's still music to my ears. It works. Oh, good evening jukebox fans. Another night, another bit of jukebox tinkering. Obviously it was really great the other night that we managed to get some noise out of the amplifier. And played a record for the first time in probably a very long time. However, I've since replaced those crappy speakers that I was testing with for something a little bit better to see what it would sound like, and to be honest it was a bit disappointing. It's a bit low and it's a bit distorted. There's something not quite right with this amplifier. I don't know what exactly, but fortunately the service manual does go into great detail about how you can check a few things and give it a bit of a going over. So this evening I'm going to be having a look at the bias adjustments on the power output stage. I'm wondering if after sort of 40 plus years of sitting around it might have drifted out a bit. That might be what's causing the distortion. But we'll get the test meter out and we'll have a look, see what's going on. Okay, well let's get stuck in then. The manual says the voltage at point A, 64 volt DC, should be half a voltage B, That's point A there, and that's point B there. So we need to measure the voltage at that point and that point against ground, and one should be half of the other, but the manual's not very clear about which one should be the higher, but I'm sure the meter will give us a clue. So I'll put that to ground and see what we get across that. And we're getting 63.5 on that side. So this should be about 32 in theory. 31.87. That's pretty close. Right, those are the adjustments I'm talking about. That's left and right sides of the amplifier. The yellow one adjusts the current drive, and the red one at the bottom, that's for setting the voltage. Now, I haven't got as far as setting the voltage because it's pretty close anyway. What's more concerning is that according to the manual, you disconnect this wire here and put a milliamp meter between it, and you should be able to read the current drive, and you tweak this little pot here to get somewhere around sort of 20 milliamps. Having put a meter across it, we're getting nothing whatsoever. There is no current drive. That can't be right. So further investigation needed. So it does look like it's back to the drawing board for these amplifier driver boards. Any distortion, I think this is going to be the first place to look. I've already noticed there's a couple of components on here that have got a bit out of tolerance. If we take these two resistors here and here, for example, it's supposed to be a 100 ohm resistor, which that one is as well. And if we put the meter on it, now obviously testing components in circuit is not the most reliable way of doing it, because you can have a situation where other components elsewhere in the circuit can affect the reading a bit, but it gives you a vague idea. When you've got two to compare by, it gives you a clue. You can see this one's reading, what's that, 106 ohms, so that's pretty close to what it should be, and if you took that resistor out of the circuit, it would probably read properly. But that suggests that one's probably okay. But if we do the same test on this identical board on the other side, with this rather old 70s resistor, just wait for the meter to settle down, and we're getting 193 ohms. So that resistor, it hasn't quite failed yet, but it's going that way. The resistance has increased quite significantly. So that's one component I've found so far. There's a couple of other of these old resistors seem to have shifted out of tolerance, and I think it probably means I can forget my big talk about not changing electrolytics and things like that, because if the resistors are going bad, you know, these boards, they obviously get quite hot because you've got the heatsink with the transistors behind them, and if I've got to have the boards out and replace components, I might as well swap these electrolytics out. I mean, there's only 3 per board, it'd be daft not to while I've got it apart. So I think quite a rebuild to go on with this. We'll change the resistors, we'll change the caps while I'm at it. I'm also going to have a look at the transistors underneath and see what state those 2N3055s are in. Right, let's have a look at this capacitor just out of curiosity. I'll unstuck from there, and there, that comes out easily enough. There we go, it's a rather elderly, early 70s effort, as of course all the bits on this thing are. And I've got my trusty little meter thing here. Useful little gubbins this, bought it on eBay for about £8 I think it was. And it's just one of these sort of all-in-one circuit tester things, and it's good for measuring capacitors and testing transistors. It's just a bit more advanced than just a standard multimeter. So I'll just connect 2 wires to this old electrolytic. I'll fire it up and we'll see what it says. Don't know if that's going to come out on the camera or not. It says it's testing, and it says it's an inductor of 15.6 ohms. It doesn't even recognise that is a capacitor. That tells me there's something not quite right there. I think that's due for replacement. Stick a bit of heat shrink over that, a bit over that, and shrink it off a bit. Why is that not going in? Come on. There we go. Push that down. And that's the first of 3 new caps that are going on this board. So there we go then, that's the board with the 3 caps replaced and that big resistor down there in the middle. I've also lifted one side of each of these resistors off the board so I can do a proper measurement. Some of them are better than others. I mean, that one's bob on, but these others, I don't know how much that's due to them slipping over age or just the fact that they're old resistors and tolerances back then maybe weren't as tight as they are now, but I think for the sake of a couple of pence I might as well swap these for the modern equivalent as well. I've just realised I left my supply of resistors back at the shop, so I'm going to have to drive down there this evening and do the resistor swap out. But in the meantime, let's get this second board out and we'll see what state the caps are in on that one. There we go. There's another one. Yeah, my suspicions have been confirmed by the circuit tester. This little capacitor, it doesn't even recognise that it is a capacitor, it thinks it's a 15 ohm resistor, so I think we can safely say that needs replacing. Right, back to the workshop then. Need to find some resistors. What do we got? 2.7k, that should be in here somewhere. There we go, assortment of resistors, that should get me going. Okay, we've got some resistors now, so I just need to put some of these onto that. There we go, one rebuilt pair of driver boards. Right then, so that's the driver board sorted out. Next job now is to tackle the output transistors. I took the heat sinks off the other night and had a bit of a look. Took the transistors out and put them on my component tester, and it turns out they're not all that great. They all still function, but the HFE or the beta or the current gain on each one, they're wildly different. Now 2 and 3055s do vary enormously. You'd expect an HFE between sort of 20 and 70, that's pretty normal. But one of them was down to 12, 2 of them were around sort of in their 30s, one was in its 40s, so really only one of them needs seriously looking at. But for a push-pull amplifier I'd rather have matching sets of transistors, and for the price of them I've got 4 2 and 3055s ready to go in, so we'll swap those out. So here's one of the amplifier heat sinks. You can see here this one has been replaced at some point in its history because the other amplifier has got 3 of those, so I'd say that those 3 original, that one's been swapped out, and if memory serves that's the one that was trouble anyway. So fortunately they come out quite easily. You just unbolt them and they're mounted on a little plug and socket arrangement, so no soldering required, just add a bit of heat paste and pop them in. One transistor, just like that. Well, there's a new transistor. That checks out nicely on the meter. We've got this little, I think it's mica, it's an insulator that when you bolt it to there, it doesn't actually make any electrical conductivity to the heatsink. We don't want that. I've got a bit of a heat gunge here. You can use the white silicon stuff. I've got this stuff here. I don't know quite what the difference is, but it's what I've got handy. So paint a bit of the heat compound on. That just helps the heat from the transistor transfer to the heatsink. Stick a bit on this insulatory thing as well. Which way around do we want that? Like that. Yeah, I want a bit. That will stick to the base of the transistor then. And you need a thin film of it, so it just helps the heat escape the body of the transistor. There we go. Bit of that on. stick that to the transistor back, and that should just plug straight in. Just like that. Screw it back in. That seems happy enough. Right, and we'll do the rest of them. Right, well that's the amplifier drivers and the output stage rebuilt. I think the next thing to tackle is the capacitor board down here. Now these two silver beasts here, those are the output caps between the amplifier and the speakers, and it's vital that these things stay working. I think they're alright at the moment, otherwise it just wouldn't work. But if they ever fail, the DC blocking caps, so if they ever go wrong, it'll send the speakers sky high, so I think it's probably worth swapping those out to be on the safe side. Of course, you've got the mains filter capacitor here. Again, I think it's probably alright at the moment because I haven't heard any humming noises coming out of it, but given the state of the others and while I've got it apart, might as well swap it. Then that leaves these two Siemens ones down here. Now, two identical ones on the board have failed, so it makes sense to swap those out, and we've got a little electrolytic here. I think that's something to do with the mute relay. So yeah, let's just change them all out to be on the safe side. Okay, well that's got the board out. Unfortunately, I had to take an awful lot of photos of all this wiring, so hopefully I'll be able to put it all back together again. But here's the board itself. Now I've got it out. Do a better job of swapping these caps out. There we go. That's another little bit of recapping done. That's the capacitor board for the amplifier. You can see the replacements are quite a lot smaller than the originals, but according to the data they should do the job. In fact, some of these have got a higher working voltage than the original, but yeah, they're a fraction of the size. It's just got to put it all back into the amplifier chassis, see if I remember where all these wires go, and hope it works. And there it is, all put back together. So we've got the two rebuilt driver boards, we've got the capacitor board there, and if you look inside there you can see that original filter capacitor that was taking up so much space. The equivalent is a lot smaller. But the question is, will it work? I'm thinking first thing I'll do when I plug it back in, we'll have to check the DC bias, because chances are these voltages and current draws have probably changed a bit now. We've uprated the components a bit, so these two adjustments there and there, they'll need adjusting, I think. So we'll get some power on it, we'll get the multimeter on it, and we'll see where we're at. Right then guys, it's all put back together. I think it's all wired in as it should be. It is that moment of truth. I'm going to have to put some electricity up it and hope it works. And you know what, the amount of years I've been messing about with electronic things, and even now when it comes to putting the plug back in for that first time, it never stops worrying me what's going to happen. But there's only one way to find out. I really hope this works. Okay, well we've got a hum. Oh, we've got something melting. Oh, fucking hell. We've got smoke. Shit the bed. Oh, what's going up in smoke there? Yeah. That big 2-watt resistor I put in is getting very, very hot. Shit. Bugger. For a minute I thought we were getting somewhere there. What's caused that?